Now here we're going to do the derivative of the function e to the x and functions of the form e to the g of x. E is the number e. Check a calculator. A calculator will have a key for e, like there's a key for pi. E is an irrational number. It has a decimal expansion that never ends and never repeats or has any group of repeating digits. It's approximately equal to 2.718. Okay, so that's a number. And it's a very remarkable number, and one of the reasons is this formula right here. The derivative of the function e to the x is e to the x. This is totally different to anything we've seen with derivatives so far, because it's saying that for this function, e to the x, the graph of which looks something like this, the value of the derivative, meaning the slope of the tangent line to that graph at a particular point, is equal to the value of the function. The slope is equal to the value of the function. E to the x is actually the only function in the world that works this way. The only function which is its own derivative. And so that's pretty cool. And that's different to anything we've done before. I mean, think about derivatives. We've done a lot of derivatives. And taking the derivative of something changes the function up till now. This is the one function, e to the x itself, for which the derivative of this function, e to the x, is the function e to the x itself. Okay. Now, what happens a lot of times is we have e, the number e, raised to a function. Even if we look at our first example we're going to do in a second, we have 5x as the exponent. Not just x, but 5x. Okay, so in that type of situation, we have a formula which is based on the chain rule here for the derivative of e to the g of x. That is e to the g of x. Copy it over, and that part comes from the formula for the derivative of e to the x. So for the derivative of e to the g of x, that's equal to e to the g of x times the derivative g prime of x. And so we'll need that when we do example 6. We'll also need the product rule, because here we have u equals x and v equals e to the 5x. So u prime is equal to 1, and v prime, here's our thing, this rule up here, this formula, e to the 5x. So g of x at this moment in this problem is 5 times x. So g prime of x is 5. So applying this formula, we'll have v prime equals e to the g of x, so e to the 5x, times 5. And that's, it's kind of a little example right there, but that's how things are going to work with e to the g of x always. We'll take, and we have something like v equals e to the 5x, and we need to take the derivative, find v prime. We'll write e to the 5x, write it, so copy it as is, e to the 5x, times the derivative of the expression in the exponent here. Okay, so now we need the product. To answer this question, what is y prime? We need the product rule, u prime v plus u v prime. U prime is 1 times v was e to the 5x plus u, which was x, times v prime, which was e to the 5x times 5. So this will be e to the 5x, factored out, times 1 plus 5x. In example B, we're going to have to use the chain rule on both of the first two terms. This is x squared times e to the x. And then we're going to have another, not chain, we're going to need, I think I said chain rule, we're going to need the product rule, x squared times e to the x. And then we're going to need to use the product rule again with 2x times e to the x. Okay, so let's call u1 equal to x squared and v1 equal to e to the x. I'm working on the first term here, x squared times e to the x. So u1 prime would be 2x, and v1 prime would be e to the x. Okay, so I'm going to come over here and write down y prime equals, here comes the product rule just for this. So it's going to split into two terms using the product rule. Remember, the product rule is the derivative of u times v equals u prime v plus u v prime. So here we go. Y prime equals u1 prime, which is 2x, times v, which is e to the x, plus u, which is x squared, times v prime, which is e to the x. u1 is x squared and v1 prime is e to the x. So those two terms, that's the derivative of the first term in the problem. Now, from that, we need to subtract the derivative of 2x times e to the x. So we'll have another use of the product rule. u2 equals 2x, and v2 equals e to the x. So u2 prime equals 2, and v2 equals e to the x. I'm going to shift this down below so I have more room to operate. And we'll have a minus now from the problem, if you will, up here, the minus sign. So minus u2 prime, which was 2, times v2, which was e to the x, plus, from the product rule, u2, which was 2 times x, times v2 prime. v2 prime is e to the x. Okay, and then back to our, those two terms are the derivative of the second term in the problem. The last term in the problem is not a product. It's just plus 6 times e. Well, it's a product, but it's the number 6, so a constant. So we don't need that product rule. So we'll have plus the number 6 times the derivative of e to the x, but e to the x has for its derivative itself, e to the x. So there's our, not quite our answer, but that's our work of taking the derivative. So 90% of the way there. So we'll have y prime equals 2x e to the x plus x squared e to the x minus 2 e to the x minus 2x e to the x plus 6 e to the x. And then the 2x e to the x's go away, and we get y prime equals x squared e to the x. Negative 2 plus 6 is plus 4 e to the x. Or y prime is equal to e to the x, factored out, times x squared plus 4.